Out of everything we do, the act of seeing requires more brain power than any other task. At least 1/3 of the brain is devoted to vision in some way. Most of us consider sight our precious and primary sense.
Oh, fabulous, fabulous. Okay, do it again.
To Howard Schatz, it's also a pretty good living.
Okay, now you're gonna dunk like Shaquille O'Neal.
In fact, he's made more than one career out of his sense of vision.
Yeah, like that, like that.
He started as an ophthalmologist and found an outlet through photography.
In medicine, one can't fool around, one can't experiment, one can't just try things because of the consequences of doing harm. Ah, good! In photography, we can play, we can goof around, we can be strange, we can be crazy. Photography allows a wild creativity, and it's safe. Slightly this way, Matthew, toward 11 o'clock. Now let me get one last focus.
In many ways, our eye resembles a camera. Our pupil works like an aperture by controlling the amount of light let in.
That was great. Now turn this way. Up a little high. Look to the
lens of our eye brings an image into focus and inverts it.
You're rising.
So does a camera lens.
Lower, Phoebe.
And the retina absorbs light like the film of the camera.
That was great. All right, I think we got it.
The similarities stop there.
1 second. Okay, go.
The camera, all you want is to reproduce the image, whereas with the eye and the brain, you're trying to create a symbolic description of the image. You're not trying to create a replica of the image in the brain. And that's the fundamental difference between seeing and taking a photograph.
Howard Schatz broke new ground in the world of photography through a series of pictures taken underwater. The result goes beyond simply capturing an image. It's his vision of pristine beauty. It will take some time before watching the world has such rich meaning for Cog. Cog is learning to see with its own cameras that mimic human eye movements.
Cog's primary sense is its eyes. And you see here, each eye has a camera which gives a wide-angle view of the world and another camera which gives a narrow-angle view of the world, the fovea that we all have and we move around. And Cog's eyes move around from place to place. When it sees something up in the distance, it will move to look towards that rapidly as our eyes move. On Cog right now, the cameras are black and white. Color's a very tricky thing, and most animals don't do color in the same way we do color. It looks at motion, and we're working on systems so it looks at depth. So when the eyes verge on something, it can tell whether something's in front of or behind the point that those two eyes are converged on.
While Cog's cameras take in fairly clear images, its computer brain can cope with only a small fraction of the incoming data. For now, a Cog's eye view looks something like this. What we call seeing begins with the light-sensitive cells of the retina. There are two kinds of cells. Cones give us resolution and color, and rods allow us to see at night. These receptors fire off signals to the brain's visual cortex, which is divided into at least 30 areas. Each handles a different aspect of vision, such as color, motion, form, and depth.
Now, clearly there are different specialized areas of the brain concerned with different aspects of vision. But you don't see some sort of collage, a fragmented visual world. You see a unified picture of the visual world.
No one knows how we end up with a complete picture. Problems with vision can happen in any number of places. Dr. Oliver Sacks has spent his career studying patients with a range of sensory disorders and documenting their stories. He recently focused on color blindness. The perception of color begins with the 3 types of cones in the retina. Each cone picks up one primary color of light: red, green, or blue. Most color disorders are caused by problems with one type of cone or another.
Very rarely, if there are no cones at all in the eye, you may get a total color blindness, which is sometimes called an achromatopia. And then people only have rods in the eye, they only have rod vision.
The brain has just as much to do with seeing as the retina. Damage to the area of the visual cortex where color is processed may knock out not only the perception of color, but even the very memory of it.
This happened with a patient of mine following a head injury. He was an artist who was famous for his use of color, and this was absolutely devastating to him. He suddenly found himself in a gray world. His paintings no longer had any meaning for him because color was such a vehicle of meaning. And when he closed his eyes to imagine color, to imagine what an orange looked like, it didn't work.
The painter continued to create striking abstractions. He learned to add color, although he never regained the ability to see it. In another well-documented case, a woman suffered a stroke and damaged the area of the brain that detects motion. She now sees in freeze frames.
She cannot see movement. She will see cars and people perfectly clearly until they move, and then they vanish, and they will come back as stills. And it's sort of confusing. She will see a car up there, and then it vanishes, and then it's going to be down here as she crosses road by sound. We take movement so much for granted, even more perhaps than taking color for granted.
During the act of seeing, the brain has to make many assumptions. Without them, we'd be overwhelmed trying to analyze the millions of bits of visual information we receive each second. One line is clearly longer than the other. The brain makes an assumption because of the arrows at the ends. The brain concludes that there are 3 different-sized people here. The one farther back seems larger. The lines created this illusion.
One simple example concerns a built-in assumption that most objects in the world, but especially faces, are convex.
Our brain doesn't like a hollow face, so we see it as convex, even when it isn't. The brain may even prefer a vase to a face.
Either you see a central symmetrical vase, or you see 2 faces. And the remarkable thing is, when you see one, you don't see the other. The 2 percepts are mutually exclusive. What it's telling you is that perception is always an opinion. It involves judgment by the observer.
Ultimately, vision is subjective. Our brain takes a few clues and invents a visual world.
I think that the idea of seeing has lots of meaning. There's what is actually there, and then what we feel about what's actually there and how we process that.
So when Howard Schatz takes his camera underwater, he captures moments of pure beauty that couldn't exist in the world we see every day. The result is a scene our brain can interpret as an illusion. What Schatz sees is not what you see, it's not what I see, and it's certainly not what Cog sees. Thanks to our brain, we get it. Cog would be terminally confused.